Hi, this is Duncan Munro, and I thought I'd spend a few minutes talking you through what's happening on the development of PSUD3. Now, it's not finished yet, but there's been sufficient development done that I thought I could share with you what's happening and maybe get some feedback on it. So there's a couple of key changes. The first is in the schematic editor. Secondly, in the simulator, which is an all new ground up rewrite. And thirdly, in the Rectifier database, which is another great new feature that I think will make the software so much easier to use. So let's talk about the schematic editor first. And you can see from the visual, there's no chart on there. So the whole of the screen area is, able to be used for looking at the schematic. And the reason you'll need more room will become apparent in a few seconds' time. There's simulator has been hived off to another tab. There's some tabs along the bottom here, and then I'll do up to 4 charts so that you can have different groups of voltages on each chart, so they don't get cluttered up or you get the scale and the context all wrong with them. So I think that will be helpful as well. So coming back to the schematic editor, the first thing you'll notice is that it uses vector graphics instead of bitmap graphics, and that's quite nice because it allows you to scale the schematic up and down with zoom in and out, or you can zoom to 100% or zoom to fit the screen. It also makes the printing so much neater. So this has really come off nicely, and I'm really pleased with the way this has worked out. There's a couple of new filters over and above PSUD2. There's a resistive tap which you can put in the middle, and there's also an RZC filter, which is resistor, zener, capacitor. So there you go. There's the block there. So not a massive need for that, I don't think, but at least it's there and you can use it if you want to. But I think the big ticket item here is the introduction of splitters and streams. So what a splitter does is it allows you to go downwards as well as going over to the right. So we can put some more stuff in there. We can insert another stream into that. So we've now got 3 streams here. And we can put LC filter in there maybe. So you can see that, let's shrink that to fit. So you can see that you can get quite complex power supplies put together with this. So that, as I say, I think that's worked out really well. You'll see some numbers in blue circles. These are node numbers, and these are used by the matrix solver, and they'll also be used by the charting side of things when that's finished. You can turn them on and off with the N key to turn nodes on and off, so if they annoy you, so it's easy to get rid of them. So that's the schematic editor. Quite pleased with that. In terms of your old PSUD2 files, there is an import facility. So you can just import. I'm just going to dump that. And these are the examples that come with PSUD2. Oh, you'll notice that the vacuum tubes now have got a proper nice symbol for them. And the other thing is the transformer on the full wave power supplies has the ability to have different voltages in the secondaries and different resistances. And that's typically a real world thing with the 2 windings. One is going to take a longer length of copper wire than the other, and it's going to have a different resistance. So it allows that to be modeled as well. The simulator, let's go on to that now. You can use the F9 key to simulate, or Control F9 for draft, or Alt F9 for quality. And I tried to make it a little bit more accessible because I think what you're going to do is you're going to run draft quite a number of times, and then when you get to where you're happy, you might bump up the quality. Now, if you look at the timings for this, so that takes 0.057 seconds on draft, 0.082 on normal, and 0.31 on quality. So the further right you go on the buttons, the better the quality is, but obviously the longer it takes. So what do we mean by quality? This is accuracy compared to what the right result should be. So draft, don't be put off by that, because that is actually 1 or 2 orders of magnitude better in accuracy than PSUD2. Normal is fairly accurate, and it's almost as accurate as Spice. when it's been forced to do small time steps. And quality is even better than spice. So spice sits somewhere between the normal and the quality one. Some of these other parameters, you've seen those before. They're on PSUD2, like the soft start. I'm playing around with the idea of putting a vacuum tube warm up in there, because these things don't come alive straight away. They pause for a bit and then they start to warm up, and then they get to full temperature. So I might put that in there as well. And finally, there's a temperature box down here, which is 300.15 Kelvin, which is 27 centigrade. Now, the reason that's in there is because the Rectifier database now does a hybrid of the SPICE model and the old PSUD2 model. So you can still use the old school one if you want, but if you want to add SPICE modeling for the forward part of the conduction, then you can do that, and that does give some more accurate results on the solid state items. So talking of rectifiers, that's going to take me now to the Rectifier database. So here we have the Rectifier database, which I think you'll like because it keeps everything together in one place. It makes it really easy to search for things, because you can put in the type of rectifier you want. So I could say solid state. By the way, you've got some new types, which is Schottky and Zener. They don't do anything different from the solid state, but they're just the schematic symbols different, so it looks a little tidier. But you can search for solid state rectifiers, and I want a PIV minimum of 1000 volts, and then it'll filter them down. If you know the part number you want, you can simply key in the part number. Let's clear all that out, clear the filters off. If you know it's a GZ34, you can type GZ and it will go find what you want. But let's look at this 1N4001 for a minute. And you've got in there the parameters, which is you'll be familiar with. These were in the rectifiers text file. There's a data sheet which you can key in items from the data sheet, and the purpose of that is you can go to the chart tab and see the dark blue line, which is the data sheet values, and then the green line, which is what PSUD has calculated. And there's a very, very basic solver in here you can use to try and get the two to line up a little bit better. So there you go, and you can save that or discard it. You can export these rectifiers either singly or for the whole lot, so it does give a lot more flexibility than was there before. Okay, so the last thing I want to show you is to go back to the editor, and we're just starting off with a new file here. So I'm going to press F9 to simulate it. You notice that when you do that, it automatically goes to the Simulate tab. You don't have to take it there. And I'm going to export this CSV, and I'm going to call it test.csv. There you go, that's done. So now we've opened up the file in Microsoft Excel. How many records is in it? There's 50,000 records, so it's quite a big one. And we can do some charting. So this was the bit that I did get asked for quite a lot, was the ability to have chart data. So if I just quickly put a chart on here, I'm not trying to do anything massively clever, just give you a flavour of what can be done. So there you go. So if the internal charting isn't going to be enough for your needs, you can go for external stuff, and you can chop the data around and analyze it and whatever. So that's it. Charting still to be done. Some other stuff, documentation things still to be done. So I'm about a month or two away from where I need to be in terms of getting something out in the streets. But I thought I'd share with you what I've got, and I hope you enjoyed seeing what's happening behind the scenes with PSUD3. Thanks very much.